Alright? What is a parallelogram? Okay, Annalise, can you describe a parallelogram for me? Based on a diagram. Let me show you the diagram. There you go. What comes to mind when you hear parallelogram?
All the lines are parallel.
All the lines are parallel? Or do you have...
I'd say two or more have to be parallel.
Two sets of lines are parallel, because this side is not parallel to this side, but rather this side right here is parallel to the line over here, and this line is parallel to the one above. So you have two sets of parallel lines in a parallelogram. Alright? Let's write that down. And you can go to page, for me, in the book, follow along with me. You can go to page 269. So let's write this about parallelograms. Parallelograms, so you say two sets of parallel lines. But not only that, right? Let's put my screen here. There we go. Not only that, the opposite sides are equal. The opposite sides are equal. And the opposite sides are also parallel. Okay? Each angle inside of a parallelogram measures exactly dash degrees. I'm going to show the diagram again, and I want somebody to tell me now. For a square, how much did each side measure?
90 degrees.
90. And when you add all four, you get 360 degrees, correct?
Yes.
Same thing for a rectangle. Each side in a rectangle measures 90 degrees. So when we look at a parallelogram, alright, each angle in a parallelogram is 90 degrees as well, because it's an enclosed shape. Good morning, George, Michael, Aliana, Isabel, and Caleb. Welcome. We're talking about parallelograms today, and I sent the link to the virtual notebook because I've realized since recent class a lot of you guys have stopped taking notes. Alright, I'm gonna go back to this until I get you guys to be more consistent in your notes. Alright, so we looked on the comparison between squares, rectangles. We said that the formula for calculating the area of a square is L squared, and we explained why. Benjamin, quickly explain why again.
Wait, what?
Why is the area of a square L squared and not L times W?
Oh, it's because all sides are even on a square.
Alright, so right for me, the reason the area of a square is L squared is due to the fact that all sides have the same length, which is 4 times L, right? 4 times L, or you can simply say, or L squared. Everybody have that down? Let me just quickly zoom out. Let me put 4 times L, or L squared. Alright, so this is the reason, right, why square area does not include width. Everybody have that down? Let me see who's here. Yifeng, are you there? Camera on for me. There you go. Okay. So that's what we've been talking about so far. We talked about the fact that a parallelogram, let me show you the diagram again. is a set of parallel lines. Isabel, which two lines are parallel in a parallelogram? Let's label this A, B, C, and D. Which two lines are parallel?
Wait, could you label again? Let's change.
Alright, quickly. Let me just draw it right here. So draw this diagram for me. Let me draw it right here. So let's say this is my parallelogram. Right? Here we go. And let's say this is part A. Trying to mark my camera.
Sir, before you go into that, sir, I have a question.
Yes?
My question is, when am I gonna have chess class?
At 3 p.m. today. 3 p.m. today.
Sir, but like, for the Scotia Bank something,
Oh,
it's like
1 to 4, right?
yes, sir.
Okay.
1:30. So look at we have to adjust it to 4 o'clock.
Alright, I'll adjust the time. I'll let the other members know. Thank you for letting me know.
Okay.
Yes?
In the notes, it says each angle inside of a parallelogram measures exactly that degrees.
Yes, dash degrees. So that's what right now. That's how I'm drawing the diagram now. So I was saying now, if a square, look at this one now. If a square has each side measuring 90 degrees, and if a rectangle is the same thing. If you go here is 90 degrees, 90 degrees, 90 degrees, and another 90 degrees. How much do you think each side will measure in a parallelogram? Anybody? Wouldn't it be the same 90 degrees even though it is alternated at a slant, right? Each side in a parallelogram still measures 90 degrees. And we call these the interior angles. Alright? So put this for me. The interior angles in a parallelogram all measure 90 degrees. Alright, now Isabel, I was asking you a question now. If I have, for example, A, B, C, D, which two groups of lines do you see as parallel?
B, C, and AB.
Right? Well, there's also another set of lines. Isn't DC and AB parallel as well? So there are two sets of parallel lines. Parallel lines that go along the line AD and BC, and there's parallel lines going along DC and AB. Right? Yes?
You said that all the angles in the that shape is 90 degrees, but DCB, that angle, it kind of looks like an acute angle.
No, that's because of the sketch. Let me give you the accurate drawing. Here you go. So even though it might look like an acute angle which is less than 90, right? An acute angle is less than 90. Each of the four interior angles inside still measures 90 degrees. Alright?
But ABC looks like more than 90 degrees as well.
Alright, we're gonna prove each of them is 90 degrees. So when you draw the when you finish sketching the drawing, we're gonna calculate the angles inside to prove it to you. Alright? So quickly do that for me. So we know y square's area does not include a width. You can cover that up. We know this is gonna be the sketch of a parallelogram. A sketch of a parallelogram. Alright? Now the next thing that we must understand, alright, is the properties of a parallelogram. The properties of
4 minutes, I'll take a screenshot.
Alright. You want to take a screenshot? Okay. 1 second. Let me go full screen. Make sure you still have it in your book though. Alright? There you go.
Yes, sir.
Alright. Have you taken the screenshot?
Yes, sir.
Alright. 1 second. 1 second. There we go. Let's go back over here. Let's put this over here. Alright, let's continue now. Let me just enlarge the screen a little bit. Great. So the properties of a parallelogram. Let's describe this diagram right here. The opposite sides we said are equal above here. Let's put this down here. That's the first one. The opposite sides are equal. The opposite angles are also equal. Alright? So, Isabella and Annalise, everybody, this angle is the same angle over here. Okay? And let me prove to you why it is actually 90 degrees now, Isabel. Alright? So let me finish at this first. The opposite angles in a parallelogram are equal. For example, angle A equals angle C and angle B equals angle D. Alright, in any shape, all angles must add up to how much? For example, all the angles in a square add up to how much?
90.
All the angles, let me go back on the sketch. All the angles in a square add up to how much? This is 90 degrees, this is 90 degrees. 360. All the angles in a square adds up to 360 degrees. All the angles in a rectangle, we have 90 degrees, 90 degrees, 90 degrees, 90 degrees. How much is that as well?
360.
Right, so follow the trend. All the angles in a rectangle adds up to 360 degrees. Alright, can you make any comparison? Are there any characteristics that a square, rectangle and parallelogram share? What is similar about them?
They all have 4 sides.
Excellent. So really and truly, we can therefore make the assessment that a rectangle is a special form of parallelogram. Isn't that true? Look at it. I have 2 sets of parallel lines running across and below, above and below, and then I have 2 sets of parallel lines again running across from each other. Right? The only difference is that a parallelogram now is slanted. You see that? Right? So a rectangle is a special form of parallelograms. Alright, everybody? They still have the same 4 sides, and all sides in a parallelogram will add up to 360 degrees. So here's what we're going to do now. We're going to know how to calculate the area of a parallelogram, and the formula. We're going to calculate the formula. Did everybody take this off? The properties of a parallelogram? We're going to calculate the area of a parallelogram now. Here we go. The area. Turn back on my camera. There we go. Back over here. There we go. The area of a parallelogram. Okay. How do we express area again? We say it is A. Right? Capital A. So the area A is going to be equal to B times H. Let me put it in a formula for you. A is equal to B times H. Michael, what does the B stand for? Where B stands for, look back on your notes from triangle. What do we say B stands for in triangle yesterday? So one goes to Michael. Michael, are you there? No. What does the letter B stand for? Is it height? Is it
base?
Base, right? Let's put base. right? And what does the H stands for? Where H stands for height, right? Okay. So with that said, we're gonna now know other methods of calculating the area. Because let's say now that I gave you a question. I'm gonna quickly give you a question to calculate. Here we go. Let's quickly see if I have a diagram here for you to calculate. Given that we have this parallelogram, let me see right here. Here we go. So draw this parallelogram for me in your notes. It is 10 millimeters. Let me paste it in the virtual notebook. Right here. Does everybody see the diagram?
Yes, sir.
Yes, sir.
Alright, we're going to have to calculate it. So put this for me. Class activity. Calculating area of a parallelogram. Okay. Now, do we have any sides given? Did they give us any side in this parallelogram? Can you repeat that for me?
No, sir. Yes, they gave the measurement for one side, sir,
Right.
not all.
They
Right.
give the measurement for two sides.
Excellent, Isabella. Tell me why they gave us the measurement for two sides. Before you write, let me put the name first. Isabella.
Sir, I know why, sir. I just remembered, sir.
Alright, good.
Sir, the measurement for one side is the same measurement for the other
So the
side.
part-
Squares, rectangles.
So the side is opposite to it measures the same, right, Isabella and George?
Yes, sir.
Excellent. So if you see 10 millimeters given, that means there are two sides that measures 10 millimeters. Okay, that's the first step. Second step, let's go to G. One second. Oh, I was on the wrong question. It's D. My bad. It's D. Here we go. This is the question. My bad. We haven't done the rhombus as yet. That's the next one. So let's copy this one instead. My bad. Alright. 1 second. Alright, there we go. 1 second. It's just taking a moment to upload. There we go. So if you're on a notebook, and everything that I'm doing here should be automatically updated on the notebook. Here we go now. No.
Yes, sir. I see it.
Alright, good. So it's the same idea. So that was excellent reasoning, George and Isabella, right? When you said that 10 millimeters would be seen for both. But really and truly, don't you see some arrows on this diagram? Do you see any arrows anywhere? Yes. So here's what those arrows mean. Put this on me. The arrows shown on a diagram means those two lines are parallel. Alright, so do you see any line with only one arrow?
Yes, sir.
Right, what does it measure?
6M.
6? No, that's incorrect. Who else? Let's see. Kira?
Oh, 6M.
6 cm, right, 6 centimeters. That means it's going to be two sides that measure 6 centimeters. Kira, what's the next side with two arrows now? So there are 7. Yes. And that because you see two arrows, right? This side over here also has two arrows. So this side will measure the same 7 centimeters. So we know all the sides of this parallelogram. Alright, excellent. Now the next step, let's go to D, is that we're going to use the base times the height. Alright, so let's look back on this diagram here. What is the base in this diagram? This one goes to Annalise. What is the base in the parallelogram? Is it the 7 centimeters or the 6 centimeters?
6 centimeters.
Alright. The reason why it is 6 centimeters, everybody, is because this line measures the same 6 because it's the same arrow that is represented. So that means it's going to be 6 multiplied, and what's the height? Is a Annalise?
7 centimeters.
No, that was a trick question. So you are paying attention to the side of 7 centimeters. But when we measure, whenever we're looking at height has to be vertically upwards. It can't be at an angle. Alright? So, write that for me. When we're looking at height, when we are measuring height, it is typically shown as a dotted line that is at a 90-degree angle. So try again for me, Annalise. Do you see any dotted line that is at a 90-degree angle to the base?
Yes, sir. Yes, sir.
5 centimeters.
So 6.5 centimeters, right? So quickly calculate that for me, everybody. What is 6 times 6.5 centimeters?
Wouldn't that be?
Wait, can you repeat that for me?
Sir, I don't know.
39.
I hear Michael. Can you repeat that for me, Michael?
39.
39. Is Michael correct? Is he finished with this question, or is he missing something? Because if I just put
Centimeter square.
right, if I just leave 39, Michael, that could have been 39 pennies, 39 dreams I have when I was younger. It could be anything. So you need to put 39 cm to the 2. Alright, let's put that there. There you go. Lovely, lovely. Alright, so that's the first class activity on how to calculate the area of a parallelogram. So the region that we just found, Michael and everybody, was the distance inside of the shape. Everything inside of the shape. So one more time, the formula, let me highlight it for you. I'm going to put it in yellow lines. So look at this for me now. The formula for the parallelogram, one more time, is A is equal to base times height. And let me just put it in yellow so you can highlight it. And there you go. So I shouldn't hear nobody saying, sir, I don't know what the formula is. There you go. It's in yellow right there. Alright? It's base times height. Any questions about parallelogram?
Sir.
Yes?
Sir, but what if there's no right angle given?
Okay, let me see if I have an example of that. If there's no right angle given, then you can draw the parallelogram and measure it yourself. So if you have a ruler, typically they're going to give you in centimeters, right? So if you have a ruler now, let me go back on the diagram. If you have a ruler and you actually drew 6 centimeters or 60 millimeters, then you're going to say measuring that vertical height from the top down, and that would actually be your height, right? Because as you realize, if you were to use this as your height, your answer would be incorrect. Alright? See that?
Yes, sir, I understand.
Okay. Alright. But there's another way of calculating area for parallelogram. So to answer George's question, let's show the other way of calculating area if you weren't given the height. Alright? So put that for me. Method 2 of calculating area. I'm going to put the picture in the group. So if you don't have the textbook, it's on page, if you have the textbook, it's on page 270. But if you don't, I'm going to take a picture of it and you're going to follow along with me with the textbook. I'm going to just post it right now. Check the group for me, everybody. Alright, do you guys see the picture?
No, sir.
Alright, it's loading up. Tell me if you see it now. It should be with the title, area of a parallelogram, counting squares. Can everybody see it now? So same like how when we did circle last time, we counted the squares inside. The next method of finding the area of a parallelogram is actually counting the squares as well. So let's do that now. Alright? Using the counting squares method for finding the area of a parallelogram. Okay, let's start. So I want, let's see, who do we have? Let's quickly, I want Naima to quickly read that sentence for me. The first sentence. When I take register. There we go. Yes, Naima? So it says, the area of the parallelogram.
I'm coming. Using the counting squares method for finding the area of a parallelogram.
So it says right here, the area of the parallelogram ABCD can be
estimated by counting squares. There are 11 squares, each of area 1 centimeter square.
Alright. Right. So what happens is that when I draw a when I have a grid paper, we call it grid paper. Alright? Let's write that. Using grid paper, we can draw the parallelogram, and each square represents.
Sorry, sir. Can you scroll some more on that screenshot?
Oh, okay. 1 second. 1 second. Let me just move over the page. There you go. 1 second. Is that good? Wait. Let me put it on full page for you. There you go.
So can you scroll up some more?
I'll scroll up. There you go. This is a terrible sketch. Don't take a picture of that. Let me give you another sketch to take a picture of. Alright. So, using grid paper as the one you see in the book, I'm going to put it on the camera. This is grid paper right here. Each square represents 1 centimeter cube. Sorry, 1 centimeter squared. Alright, there we go, 1 centimeter squared. Right, and based on the fact of how many squares that are inside a parallelogram, we can count it. So, how many squares do you see that are fully inside of this parallelogram, Jude? In the second diagram, how many squares is completely covered in the parallelogram? Jude? Yeah, can you hear me? See, I do these tests every single day, guys. You have to make sure you're online and paying attention. Jude, can you hear me? Oh, okay. So how many squares in the second diagram is completely covered in the inside of the parallelogram? Jude? Yes, do you see it? Alright, let me give you some assistance. Alright, are you ready now, Jude?
Yes, sir.
Yes, so count with me. This is the first square. It's represented by 1, right? How many do you see? Look on the diagram in the book. Alright, so we'll get back to you, Jude. I can't really understand. Alright, we'll get back to you in a moment, Jude. Alright, let's continue. So Jude is having some technical difficulties. Let's go to Yifeng. Yifeng, are you there? Quickly.
I just noticed some the parallelogram.
Wait, can everybody hear me? I think I'm
Yes, sir.
Yes, sir. We can
Okay.
hear you clearly.
Okay, alright. So probably it's Jude and Ethan have internet issues. So when you look on the diagram, you see 11 squares completely covered inside the parallelogram, right? 11 complete squares, right? So we can say therefore there are 11 complete squares that are covered. There are 11 squares. So which stands for 11 centimeters squared. Alright? Which is 11 centimeters squared. Alright? But my question goes to let me see. Isabella, why wouldn't we say this is the area of the parallelogram?
Because there's more that are incomplete.
Right.
At the moment.
Right. And they're color coded too. So you see the red one in the right corner right here? Even though it's incomplete, couldn't I attach it to the one over to the next side and call it one complete square? Right? So that's going to be 11 plus 1. Let's try the green square now. That's going to be attached to the one over to the right. It's going to be 11 plus 1 again. So as we have plus 1. And then now we have the purple. It's going to be plus 1 again. And then finally the yellow one is attached to both sides. One over here and one over here. So that means we have 11 plus 1 plus 1 plus 1. How much does this give me as my area? 15 cm squared. Alright? Now the beautiful thing about this is that if you were given actual measurements for your base and height, Isabella, you could actually calculate that this would have been the area. Alright? So those are the two methods. In your exam, you're going to be given a diagram for you to count the squares and actually find the amount of area in that diagram. Okay? So, the steps to do this method, I'm going to take another picture and show you, and then we're going to go through it. So let's take another diagram quickly. You're going to look at it. We're on the steps to doing the counting squares method. Alright. Can you see the diagram? Just sent it in the group. Can everybody see it?
Yes, sir.
Alright. So, what does it say? It says, another way you can count the number of squares in a parallelogram, right, is by looking on the amount of complete squares that are enclosed outside of the parallelogram. Alright? So, do you see the region that are shaded pink? Can everybody see that?
Yes, sir.
Alright, follow with me now. Assume that the parallelogram is enclosed by a rubber band. Alright? Imagine that the corners are pulled, right, so that the opposite sides remain equal and parallel until a full rectangle is formed. So what it's saying, let's go back on the diagram. Here we had the trapezium, sorry, not trapezium, the square and the rectangle. Let's go back up here. So imagine that this parallelogram was pulled at this corner and at this corner until it turned into a full rectangle. Alright? Imagine that that happened. What would happen as a result is that the area of the parallelogram is going to be equal to the area of the rectangle ABEF. Alright? Everybody see that? Hello, do you guys see that? So there's a method to where you can imagine the parallelogram and then you pull this side right here to form a right angle, right? And the spaces it takes in this corner would be the amount of area for the entire parallelogram. So let's go through an example there. Alright? Assume that the part BCE is cut out. Alright? Count the number of squares that we have left in the corner. So if we start counting from this corner all the way up here, we count across, we get 5 in the top row, then 5 again, so we have 10, and then when you continue counting, you get 15. Wasn't the 15 the same amount that we got when we added the amount of squares? Right? So you can choose between those two methods. It's either you're gonna just add the amount of squares that would make a full rectangle, or you're just gonna count the number of squares and then add the broken pieces together. Those are the two ways. Alright? Okay. Now with that said, alright, I have a grid paper. So you're gonna do these 6 activities for me now. You're gonna calculate them using any of the two methods for finding the area of the parallelogram. Alright? So you have questions 1, 2, 3, 4, 5, 6, and you must use the method for at least 3. So you're going to use the area method of counting by counting the number of squares, and then now for the next 3 you're going to find the amount of area for a rectangle, and then that would be the amount for the parallelogram. Everybody understand? Alright? 1 second. Let me just quickly give you this diagram as well. So look inside the group for me. Alright, so quickly look on the final picture I just sent a while ago. That summarizes what I was just saying a while ago, right? The parallelogram on the left hand side, right? It is turned to a rectangle. So I'm going to ask 2 persons to describe it for me. What is the difference now between the one on the left and the one on the right? That goes to Kira and George. Quickly describe for me the difference you see in the parallelogram and the rectangle. What's one thing you notice?
Sir, my WhatsApp isn't working, sir, so I can't see the thing.
Oh, you can't see it? Alright. Let me bring it on the screen. Yes?
For the parallelogram, if you add all the angles, we're at 160.
Right? But in terms of its sides, we have a side A, D, B, C. Do you see another side coming out on the rectangle, and what is it called? It's brightly colored orange. There we go. Alright. Can you guys see that?
So can you please repeat the question?
Look at the diagram for this one. A, B, C, D. Right? What did we add to this diagram that is completely different?
You cut the other parallelogram, and then you'll have, the
Right. So we cut the parallelogram, right, on the left hand side over here. We cut it to form E at the top, and then we added that part F over here. So the 2 things we did, we cut it on the left hand part and we extended it on the right to form E and F. Alright, that's what you're going to be doing for those 6 questions, right, using the 2 methods of getting the area. You're going to count the squares, and then for the next 3 you're going to do this method, right, where you have the parallelogram originally, and then you're going to cut it on the next side to a 90-degree angle, and then you're going to extend the part D out to form a 90-degree angle F, AF, and EB. Alright? Any questions, everybody? Any questions? So that was parallelogram calculation. We learned how to calculate it by the formula. We learned how to calculate it by counting the squares, and we also learned how to calculate it by turning it into a rectangle. Alright? I'm going to post the recording and the homework on the portal so you can complete it before the end of the day. Alright? Have a great lunch. Take care, everybody.
Yes, sir.